So this is the second part for a review of exam 1, and now we are in section 1.4. Okay, in section 1.4 we are asked to practice number 42 and 44. So here it tells us to solve this polynomial equation. So let me choose 44. Okay, and 42 is pretty similar. So in 44 we have negative 3x to the power 4 plus 11x square equals to negative 4. So we have this polynomial equation and we are asked to find all real solution for this polynomial equation. Now this polynomial equation has the highest exponent or the power, which is 4. So this is the polynomial equation with a degree 4. Okay, so this is the polynomial equation with a degree 4. And if you have a polynomial equation with a degree 4, then there is a way to solve this kind of equation. Okay, you need to rewrite this type of polynomial equation into a quadratic form. Okay, that's the key here. And since the degree is 4, the number of solution gonna be at least 4. Okay, you can have 4 or less than 4. So let's rewrite this equation. So we have negative 3. So we have x to the power 4, and we can rewrite x to the power 4 as a square of x squared. Okay, these two are same thing. Plus 11x squared equals to negative 4. So make sure if you have a polynomial with a degree 4, then you are rewriting that polynomial equation in a quadratic form. For that, so we rewrite x to the power 4. So x to the power 4 is the same as the square of x squared. If you take square of x squared, then you get x to the power 4. Okay, then we make a substitution. So let's call our x squared is t. So let's call our x squared is t. Now we replace every x squared by t. So we have negative 3. So this x squared t, and we have the square as it is, plus 11, this x squared is t, equals to negative 4. Okay, so we replaced every x squared of the equation by t, because that's what we called here. Our x squared is t. You can call any variable. Okay, it really doesn't matter. You are not required to have t. So you can choose p, you can choose a. So you are replacing every x squared terms by that variable. Now see this equation. So this equation has a degree 2. So this is our quadratic equation, and you can use any method to solve this quadratic equation. Okay, let's use quadratic formula. And in order to use quadratic formula, we need to have 0 in one side. So let's add 4 on both sides. So this is negative 3t squared plus 11t plus 4 equals to 0. Okay, now we compare this equation with our general equation, ax squared plus bx plus c. Now here our variable is t, so you can replace this x by t. Okay, a t squared bt plus c equals to 0. Now if you compare, for a we have negative 3, for b we have positive 11, for c we have 4. So we substitute this in our quadratic formula. So our t equals to, because variable is t, so we are using t, we are not using x, equals to negative b plus minus square root of b square minus 4ac divided by 2a. Now our b is positive 11, so we have negative as it is, and 11 plus or minus b squared. B is 11, its square is 121, minus 4 times a is negative 3, c is 4, divided by 2 times negative 3. Our a is negative 3. So this is negative 11 plus or minus 121 as it is. So negative 4 times negative 3, negative 12, sorry, no, positive 12 times positive 4, that is positive 48, divided by 2 times negative 3, negative 6. So this is negative 11 plus or minus 121 plus 48, 169 is square root of 169 divided by negative 6. So we know square root of 169 is 13. So we have negative 11 positive negative 13 divided by negative 6. Now we take positive sign. When you take positive, we have negative 11 positive 13 divided by negative 6. Next you take negative sign. This gives us negative 11 negative 13 divided by negative 6. So this is negative 11 plus 13, that is positive 2 divided by negative 6. Negative 11 negative 13 negative 24, negative 24 divided by negative 6, that is positive 4. We can simplify this as a negative 1 over 3 and 4. And this is our t, okay, this is not x. If we go back to our original equation, we have our variable x, and you are asked to solve this equation, means you should know what is the value of x, but we calculated the value of t, okay, but we want the value of x. Now what do we know about our t? Our t is x squared. See, our t is x squared. So let's replace our t by x squared. So x squared equals to negative 1/3, or let's take another t value, x squared equals to positive 4. Now in order to get rid of square, we have square root on both sides, and on the right side make sure to have positive negative, square root positive negative. So this goes away, we have x equals to positive negative negative 1 over 3, and we have square root, or so this goes away, x equals to positive negative square root of 4 is 2. Now here this we have a negative under the radical sign, so this is a complex number, this is a complex solution for this equation, but we are asked to find the real solutions. But here positive 2 and negative 2, these two are a real number, so these two positive 2 and negative 2 are the real solution for this polynomial equation, okay. And this first part, this is a complex solution. You are not required to have that complex solutions, as you are asked to find only the real solutions, okay. So this is our final answer. So this is for 44. You can try, you should be able to do number 42, which is pretty similar to 44, okay. So I want you to try it by yourself. Next, 47, 49. Let me double check it. 47, 49, yes. So out of 47, 49, I'm gonna do both, okay. So we have 47. In 47 we have 5 divided x plus 2 plus x equals to negative 8. Here we have our variable in the denominator, so this is a rational equation. We are asked to find, or we are asked to solve this rational equation, okay. And the method is we need to multiply both sides of the rational equation by the common denominator, okay. So here 5 has a denominator x plus 2, x has a denominator 1, negative 8 has a denominator 1. Now let's find common denominator. So you're gonna write down every denominator. So x plus 2, 1, 1. So these are the three different denominator, and we want to find a common denominator, okay. In order to find common denominator, we need to factorize each denominator. So we have x plus 2. This is in the simplest form. There is no any way we could factorize, so we just write this as it is. So x plus 2 is a factor of itself. So 1 is a factor of itself, 1 is a factor of itself. Now for the common denominator, we look for the common factor in each denominator. Do we have a factor which is common in all of these three? Okay, I mean, you can just write 1 as a factor of x plus 2. Okay, 1 is a factor of any number. So we have this 1 as a common factor in all of these 3 denominator, and we're gonna write once. So you're gonna just write 1 time. Now we have x plus 2. Now this is the only remaining factor, so you're gonna write that as it is x plus 2. And 1 time x plus 2, that is x plus 2. So this is the common denominator, and we use this common denominator to multiply both sides of the equation x plus 2. So you are multiplying this rational equation by the common denominator. Okay, now here we have x plus 2 times these two expressions separated by positive. So we need to distribute this x plus 2 for the first expression as well as second expression. And this is x plus 2, make sure to have parentheses, times 5 divided by x plus 2, plus you distribute x plus 2 to the next term, which is x over 1, times x over 1 equals to negative 8 divided by 1, that is negative 8 times x plus 2. Now we can cancel these two are the common factors, so we have the multiplication. Okay, so if you have multiplication, or if you have your numerator and denominator in a factor form, then you can cancel. But if you have a positive here, you can't cancel this one. But we don't have positive, we have a product sign, and so we can cancel. So we have 5 plus we need to distribute x here to this x, and positive to x times x is square, x times positive to x equals to, you distribute negative 8 here, so negative 8 times x, negative 8x, negative 8 times positive to negative 16. Now we simplify, this is a quadratic equation, so let's get rid of, let's make 0 in one side, so we add 8x on both sides, and you add 16 on both sides. So let me start by writing from a square term, x square, so 2x plus 8x, 10x, then constant 5 plus 16, 21 equals to 0. So this is a quadratic equation. Okay, you are not done it, you need to solve this quadratic equation. Okay, and we have done a lot. You can use any method to solve this quadratic equation. You can use factoring method, or completing the square method, or you can also use quadratic formula. So I want you to solve this quadratic equation by yourself. Okay, so from here you can get two answer. Okay, you can use factoring method, quadratic formula, or completing the square method. So the next we have number 49. So make sure to complete this. Okay, complete it by yourself. So next we have number 49. In 49 we have 2 divided x squared plus 3x minus 4 plus 1 over x minus 1 equals to negative 6 over x plus 4. So this is the rational equation we have. We are asked to solve this rational equation, and the very first method is we find the common denominator. So we have these 3 denominator. Now let's find the common denominator. So you write down each denominator, x squared plus 3x minus 4, your second denominator x minus 1, third denominator x plus 4. We are trying to find common denominator. In order to find the common denominator, you must have your denominator in a factor form, in a simplest factor form. Now there is a way to factorize this denominator. We use FOIL method. So what should be the first term? So that is product is x squared, it's always x, right? Now let's find two number whose product is negative 4 and sum is positive 3. So two number whose product is negative 4 and sum is positive 3. So it's gonna be positive 4 and negative 1. Positive 4 times negative 1, negative 4, positive 4 plus negative 1, positive 3. Okay, so these two are the factor of this denominator. X minus 1, it's already in the simplest form, so x minus 1 itself is a factor. For x plus 4, it's in the simplest form, so x plus 4 is the factor of itself. Now to write the common denominator, we look for the factor which is common in all of these three denominator. We don't have, but we do have x minus 1 common in two denominator. Okay, so if you have any common, you're gonna write one time, so we have x minus 1. Similarly, we have x plus 4 common in two denominator, so you are writing this one time, x plus 4, and this is your common denominator. You use this x minus 1 times x plus 4 to multiply both sides of the equation. So you are multiplying both sides of the equation by x minus 1 times x plus 4. You do the same thing, x minus 1 times x plus 4. Okay, so you find the common denominator, use that common denominator to multiply both sides of the equation. Now on the left side we have a common denominator, okay, and inside the parentheses we have two expressions separated by positive, so you need to distribute this common denominator for each expression, for this expression and for this expression. And so let me rewrite this. So we have x minus 1 times x plus 4 times first expression, that is 2 divided x square minus positive 3x minus 4 plus common denominator for the next expression, x minus 1 times x plus 4 times 1 over x minus 1. Now on the right side, let me rewrite right side, negative 6 x plus 4 times x minus 1 x plus 4. Now once you multiply each expression with the common denominator, you get rid of the denominator. Okay, now here x minus 1 times x plus 4, so this is, so x minus 1 times x plus 4 is same as x square plus 3x minus 4. So this expression and this expression is the same. Okay, one is in numerator, another is in denominator, and we have in a product form, so you cancel this, we can cancel this. So here you can cancel x minus 1, x minus 1. On the right side you can cancel x plus 4, x plus 4. Now let's write the remaining. We have 2 remaining from the first expression plus x plus 4 from times 1 from the second expression, and on the right side we have negative 6 times x minus 1 remaining. Now we simplify this. We have 2 plus x plus 4 equals to, you distribute negative 6, so negative 6x, negative 6 times negative 1, positive 6. These two are like terms, 2 plus 4 6 plus x equals to negative 6x positive 6. This is a linear equation, so let's solve this. We add 6x on both sides, subtract 6 on both sides. This is 0, this is 0, this is 0. So x plus 6x, 7x equals to 0. To get rid of 7, we divide both sides by 7. 7x divided by 7x equals to 0 divided by 7, 0. And this is the solution for this linear, sorry, not the linear, rational equation. Okay, key thing here is that to find the common denominator, use that common denominator to multiply both sides of the equation. You need to make a distribution. You need to distribute that common denominator for each expression. Excuse me. Simplify and you solve for the variable. Excuse me. So this is all about for section 1.4. Now in section 1.5, we have the inequality, and we are asked to solve this inequality. So in number 55, our inequality is 5x minus 2 less than equals to 3x plus 7. Solving an inequality is pretty similar to solving an equation. Okay, you are making variable by itself in one side. Our variable is x, so we want our variable in one side and the remaining terms on the other side. Okay, so let's collect the terms with the variable in one side. So let's collect our variable terms on the left side. So let's get rid of positive 3x on the right from right side, and for that we subtract 3x on both sides. Okay, this gives us 5x minus 3x, 2x minus 2 less than equals to, this is 0, positive 7. And whenever you are adding or subtracting a same number on a both side of the inequality, your inequality sign remains same. Okay, but if you are multiplying or dividing both side of the inequality by a negative number, your inequality sign flips. If you have less than equals to, it's gonna be greater than equals to. If you have less than, it will be greater than. If you have greater than equals to, it will be less than equals to. If you have greater than, it will be less than. If you are multiplying or dividing both sides of the inequality by negative numbers. Okay, but whenever you are adding or subtracting positive or negative number, it remains same. Now we need to get rid of negative 2, so we add positive 2 on both sides. We have 2x, this is 0 less than equals to 7 plus 2, 9. Now in order to get rid of 2, we are dividing by positive number, so 2 is a positive number, and whenever you are dividing by a positive number, this inequality remains same. It does not change. It changes only when you are dividing or multiplying your inequality by negative numbers. So 2x divided by 2 is x, less than equals to 9 divided by 2, let me write 4.5, or you can just keep 9.2 as it is. And the next thing you have to keep in mind is that you are asked to write your answer in an interval notation. So for that, you draw a number line. We have negative infinity, we have positive infinity, and we have 4.5 here. Let's say somewhere here. Now 4.5 is also a solution. Okay, you have equals to sign here, so your x is the variable, so your x is equals to 4.5 or less than 4.5. And whenever you have equals to sign, you're going to use a closed circle. Now where do we find a number less than 4.5? We find it on the left side. So this shaded region is the solution. In order to write an interval notation, we start from left side. We have a negative infinity all the way up to 4.5. We have a closed circle, means you're going to use bracket. With infinity, it's always parenthesis. Okay, so if you have a closed circle, you're going to use bracket. If you have open circle, parenthesis. With positive or negative infinity, it's always parenthesis. And this is our final answer. Okay, now let me do number 59. So we have negative 1. Okay, so we have x minus 4 divided by 3 greater than equals to negative 1 and less than equals to 4. So this is the compound inequality. We are asked to solve this inequality and express our answer in interval notation. So solving means we are making x by itself. So x has a negative 4, denominator 3, so we need to get rid of this 3 and negative 4. So in order to get rid of 3 from the denominator, we multiply each expression by positive 3. Okay, so you are multiplying by positive 3, and whenever you are multiplying by positive 3, inequality sign does not change. So negative 1 times 3, that is negative 3 less than equals to this 3 cancel. So x minus 4 less than equals to 4 times 3, 12. Next we add 4. Make sure you are adding 4 in each expression. Negative 3 plus 4 positive 1 less than equals to this 4 is 0, x greater than equals to 16. So your x is greater than or equals to 1 and less than or equals to 16. Now let's write this in an interval notation. You draw a number line, you have negative infinity on the left, positive infinity. So you're going to write this 1 somewhere here, 16 let's say somewhere here, and you have equals to sign here, so you're going to have a closed circle at 1 and closed circle at 16. Now where do we find a number? Okay, x is a number. Where do we find x which is greater than 1 and less than 16? Okay, and it has to be here. Okay, so these are the number which is greater than 1 and less than 16, and this part is a solution. Now let's write in an interval notation. You are starting from 1 and all the way to the 16. You have a closed circle on both sides, so you are using bracket, and this is the solution for this inequality. Similarly, I want you to practice 54 by yourself. Okay, next here, so we are at 59. Let me, so 59, now 61, 65, 61, 65. Okay, so in 61 and 65, so this is section 1.6. so section 1.6, you are asked to practice 61 and 65. Okay, let me do 65 for you. So we have negative 3 plus 2 times absolute value of x minus 4 equals to 7. So this is the absolute value equation, and we are asked to solve this absolute value equation. So solving means we are making our x by itself. Now every time if you have an absolute value equation and you are trying to solve this equation, you must have absolute value expression in one side and the remaining on the other side. So here, so this is the expression with absolute value sign. Okay, it has absolute value sign, so you're going to have this absolute value sign in one side and this remaining negative 3, these two on the other side. So let's get rid of these one by one. So let's get rid of negative 3. So for that you add 3 on both sides. So we have 2 times, this is 0, absolute value of x minus 4 equals to 7 plus 3, 10. Now to get rid of 2, you divide by 2 on both sides. X, so we have absolute value of x minus 4 equals to 5. Now the next we have to get rid of this absolute value sign. Now we need to rewrite this equation without using absolute value sign. Okay, and how do we do that? You take whatever you have inside absolute value sign, x minus 4 equals to positive of right side, positive 5, or you take whatever you have you inside the absolute value sign, x minus 4 equals to negative of right side. Negative of positive 5 is negative 5. Okay, so whenever you are rewriting your absolute value equation without absolute value sign, you're gonna get two equation every time. Okay, like for example, if you have absolute value of x equals to positive a, then this is equivalent to x equals to positive a or x equals to negative of a. So you always gonna have two equation whenever you are rewriting your absolute value equation without using absolute value sign. Now these two are linear equation, we know how to solve, so we add 4 on both sides for both equation. So x equals to 5 plus 4, 9, or x equals to negative 5 plus 4, negative 1, and these are the solution for this absolute value equation. So here key, so this is the key steps. So whenever you have absolute value sign, whenever you have absolute value equation, and if you are rewriting your absolute value equation without absolute value sign, you always gonna have two different equation. Okay, you're gonna write whatever you have inside the absolute value equals to positive of right side, or you're gonna write whatever you have inside the absolute value equals to negative of right side. Okay, so in a similar way, you should be able to solve 61, and if you need help, yeah, just let me know. The next we have a 66. Okay, 66 and 71. So 66, 71. Okay, let me do both here. So in 66 we have absolute value of 3x plus 10 greater than 5, and we are asked to solve this inequality and write our answer in interval notation. Okay, so whenever you have absolute value in inequality, there is a two cases. So first case, you might have absolute value of x is greater than some number a, or greater than equals to, it's going to be same thing. If this is the case, you need to rewrite this absolute value inequality without absolute value sign, and this is x less than negative of a or x greater than positive of a. Okay, so this is how you can rewrite without absolute value sign. The next, if you have absolute value of x less than a, then we can rewrite this absolute value inequality without using absolute value sign, and this is x greater than negative of a less than positive of a. Now, so we have greater than sign, so we're going to use this concept to rewrite this inequality without absolute value sign. So you're gonna write whatever you have inside absolute value sign. So we have 3x plus 10. Okay, then less than negative of right side, negative of 5, negative 5, or whatever you have inside absolute value sign, 3x plus 10 greater than positive of a, which is 5. Now we have this linear inequality. Okay, now we know how to solve this. So you add 10 on both side, you add 10 on both side. Sorry, no, we want to get rid of 10, so we are subtracting 10. I'm sorry. So you subtract 10 on both side. This is gone. We have 3x less than negative 5, negative 10, negative 15, or this is gone. 3x greater than 5, negative 10, negative 5. Now you divide by 3. We are using positive 3, so inequality sign remains same. 3x divided by 3x less than negative 5 divided by 3, negative 5, or 3x divided by 3x greater than negative 5 over 3. So this is the solution of this inequality, but we want to write in a interval notation. So we have negative infinity, positive infinity, so negative 5 is somewhere here, negative 5 over 3 is somewhere here. Okay, so we don't have equals to sign here, we have strictly less than and strictly greater than. So you're gonna have an open circle at negative 5, open circle at negative 5 over 3. Now where do we find a number x which is less than negative 5? On the left of negative 5. So this is one part of solution. Where do we find a number x which is greater than negative 5 over 3? We find on the right side. So this is the second part of solution. So let's write this in an interval notation. We have from negative infinity to negative 5, with infinity always parenthesis. We have open circle, so parenthesis. Okay, then from negative 5 over 3 to positive infinity, with infinity parenthesis, open circle, parenthesis. And we have a or here. Okay, and whenever you have or, you're gonna replace that or by union sign, and this is your final solution. So if you have or union, if you have and intersection, you're gonna replace your or by union and by intersection. Okay, the next here we have number 71. In 71 we have absolute value inequality, absolute value of negative 2x negative 7 plus 4 less than equals to 8. So let's get rid of negative 4 positive 4, so we subtract 4. We have absolute value of negative 2x negative 7, this goes 0, less than equals to 4. Now if we go back, this is the absolute value inequality. We have two cases, and this case is similar to this one, so we're gonna rewrite our absolute value inequality without absolute value sign. So you're gonna write whatever you have here inside absolute value sign. So you have negative 2x negative 7, then greater than equals to negative of this number negative 4, you have equals to here, so I have equals to here, and less than equals to positive of this number, which is 4. Now this is an inequality, okay, linear inequality, and we know how to solve this one. So let's add 7, okay, for each expression. So negative 4 positive 7 positive 3 less than equals to, this is 0, negative 2x less than equals to 11. Now we get rid of negative 2, so we divide each term by negative 2, and here we are using negative 2. Whenever you are dividing by negative 2, your inequality sign flips, so you have 3 divided by negative 2, this changes to greater than equals to negative 2x divided by negative 2 positive x, and this changes to this sign 11 over negative 2. Okay, so do not forget this. Whenever you are dividing or multiplying the inequality by negative number, it flips. Now this is the solution. Now let's graph this. We have negative infinity, positive infinity, so which one is the smaller number? So this one is the smaller number. Let's say somewhere here negative 11 over 2, and let's say we have negative 3 over 2 somewhere here. We have equals to sign on the both, so we have a closed circle. Okay, now can you tell me x, can you tell me a number which is less than, which is greater than negative 11 over 2 and less than negative 3 over 2? Where do we find this number? Where do we find x which is greater than negative 11 over 2? Okay, so greater than negative 11 over 2 means on the right, and less than negative 3 over 2 means on the left of. So you see this common region here, this is the solution. Now let's write this in an interval notation. So we have, from negative 11 over 2 to negative 3 over 2, we have a closed circle. It means we're gonna use bracket on both sides, and this is the final solution for this absolute value inequality. Okay, so make sure you practice on solving absolute value inequality. Now we have from exercise 1.3 from 9 to 14. So let me pick number 13. So in number 13 we have square root of negative 4 over 25. You are asked to write this number as a pure imaginary number. It means you are asked to write this number in terms of I. Now we have this negative under this radical sign, and if you have any number, if you have a negative number under the radical sign, these are the imaginary number. Okay, so we need to rewrite this number without using or without having negative number under the radical. So we have radical sign negative 4 over 25, we can rewrite this as a negative 1 times positive 4 over 25. Okay, what do we know about negative 1? Negative 1 is always equals to I square. So let's replace this negative 1 by I square. Our 4 is 2 square, 5 is, sorry, 25 is 5 square. We have a square root. The index for this radical sign is 2. Okay, square root of I square is I, square root of 2 square is 2, square root of 5 square is 5, and we have I times 2, 2I divided by 5. So this is not, this number is same as this number. Okay, the only difference is that we don't have negative number under the radical sign here. We are rewriting the given number as a pure imaginary number. Okay, so this is all you need to practice for your exam 1, and if you have any question with any problem, just write me an email. I'll be there to help you.